Okay, so we're on the examples where we're solving equations now. And what we're looking for is we're looking for solutions on intervals, and sometimes we're looking for solutions on the real number line. All right, what I mean by that is from minus infinity to infinity. There's a difference between the two. You'll see this clearly in the questions. So for example, number one, they want you to solve an equation, but they only want the answers between 0 degrees inclusive and 360 degrees not inclusive. That was number one. We'll go over that in a second. Number two, they want a solution to this equation. Again, same interval between 0 degrees inclusive and 360 degrees not inclusive. Number three, they want a solution to this equation, again, between the same restrictions. Number four, they're using a different measuring system over here. This is in a radian measure, not because there's a pi there, but because there's no units on the numbers. All right, over here, again, they want a solution, restricted set, but it's on a different, in the radian measure. Here's where something happens that a lot of people find very, very strange. They want to solve for x, but now they say use n as an integer constant. And the reason for that is that solutions to this thing over here are going to be repetitive, and they repeat on an interval length of 2 pi, because the sine function has a cycle length of 2 pi. Again, we'll go through that example. Number seven, same thing. They want an integer, they want a solution to this thing, but again, it repeats itself. Well, cosine function repeats itself every 2 pi. All right. Tangent function, well, integer constant again. The thing about the tangent function, it repeats itself every pi units. All right. We'll talk about that later. Cosine, again, cosine function will repeat itself every 2 pi. All right. Solve for x. 10, last one. They want us to use the n as the integer constant again. I'm going to switch to the whiteboard. As I go to the whiteboard, we're doing these problems in the example problem set. All right, so these are the examples I'm going to work through. Again, for a lot of students, this goes way too quick for them. If it does, you can always watch this at a later time. Or if you want, you can just simply watch the side videos. No problem with that. Just watch them. All right, your goal, though, is to be able to do this material on your own without saying, oh, gee, I can follow you, but I can't do it. You want to be able to do these on your own. And we're going to start with problem number one. So we're in the example equations. Let me switch screens. And I'm going to do my whiteboard now. I think I'm doing my whiteboard. Yeah, there it goes. A little slow today. All right, let's start with number one. And I'm going to tell you what the method is. Right, the method's really, really important. At least the method I'm teaching, I believe is important. So the first thing I want to do is it in the form we want? And the form we want is we want either a sine, a cosine, or a tangent equal a number. What do we have over here? We have cosine equals a number. Our recommendation is to graph one cycle of the cosine function. Well, they were kind enough to do that for me, but I want to point out, you should do this on your own. And as I said, there's really no firm numbers down here, but I would draw one cycle of the cosine function down. And that did a very good job, by the way. But you should know the characteristic points in this, and I'll put them down for you. And the characteristic points are as follows. This one over here is going to be 0 degrees. You may wonder why I'm speaking in degrees. They're speaking in degrees. That's a point 0 degrees, comma 1. This point over here is 90 degrees, comma 0. This point over here is 180 degrees, comma minus 1. This point over here is 270 degrees, comma 0. And this point over here is 360 degrees, comma 1. All right, now what do you want to do? Well, what you're going to do now is you're going to draw a line. I just did the cosine function. We're going to draw a line y equals minus 1 over root 2. All right, now where is that? That's about minus 0.7. So I'm going to say that line's about here. This is the line y equals minus 1 over root 2. This is the curve y equals cosine x. Now, did they meet somewhere? And I think it's clear as day they met somewhere. Where did they meet? Here and here. I want to point out the first one I'm looking at occurred between 90 and 180. and the second one occurred between 180 and 270. So what I want to do is I want to try to figure that out. And the way I'm going to do that is I'm going to say, do I know any references that would give me that ratio of 1 over root 2? When I talk about reference about triangles, and I'm pretty sure you're familiar with this, but I'm going to put it down for you over here. The reference is going to be a 45-degree triangle. And that would definitely give me a cosine of 1 over root 2. So what's the angle, the reference angle? The reference angle is 45 degrees. Okay? Here comes the tough part for a lot of students. What's the angle? Well, if you notice, the first angle has got to be between 90 and 180. And what would that number be? Well, you're going to be at 180, but you back off 45. So the angle would be x equals, what's the 180 minus 45 would be 135 degrees. What's the other angle going to be? And I want to point out to you, it's between 180 and 270. Well, I'm at 180, but it's a reference of 45. So I got to go forward 45 degrees. So it'd be 225 degrees. These questions have answers, and we strongly recommend that you look at the answer in the blue area to make sure that you can verify that it says 135, 225 degrees. We go to the next page. And I'm going to do problem number 2 now. All right. So number 2, again, I want to make sure I got the proper form. What's the proper form? The sine is equal to a number. The cosine is equal to a number of the tangent. I clearly got the sine. What's our recommendation? Our recommendation is to graph out one cycle of the sine function. Let me do that for you. And yes, I know they drew that for me. I'm just tracing over it. But I'm going to say that for the most part, I really can never do accurate pictures. Right? You should know key points in this picture. I'll put them down for you. This is a key point, key point, key point, key point, and key point. And I'll write those points down for you. This point over here is 0, 0. I'm sorry, 0 degrees. They're speaking in degrees. This point over here is 90 degrees, comma 1. This point over here is 180 degrees, comma 0. This point over here is 270 degrees. The reason I'm speaking in degrees is they were speaking in degrees, comma minus 1. And this point over here is 360 degrees, comma 0. Then what are you going to do? You're going to draw a line y equals minus root 3 over 2. I want to point out the red curve is y equals sine of x, a real famous curve that you should know about. Now, what's minus root 3 over 2? You should have some feel for it. It's about, I'm going to say about minus 0.9. So if you were to draw that picture, it's a line, looks like this over here. Does it hit? Do they meet somewhere? They do, right here and right here. So I'm going to say there's 2 places where they meet. Now, where do they meet? Between 180 and 270 and between 270 and 360. All right. What am I going to do now? I'm going to look for a reference triangle that meets that description. Now, what's that description? A reference. A reference can be an acute angle, right? So it's got to be an acute angle. And what do I know about that? Minus root 3 over 2. I'm going to say it looks like this triangle here, this reference triangle, a 60-degree triangle. What's that going to be? Root 3, 2, and 1. All right, definitely that triangle. So the reference is 60 degrees. I'll write that down for you. Okay, here comes the tough part for a lot of students. They got to figure out what's the angle going to be. But I want to point out the first angle is between 180 and 270, but the reference is 60. So what do I got to do? 180 plus 60, which would be x equals 240. The next angle is going to be between 270 and 360, but the reference is 60. So I'm at 360, back off 60, you'd be at 300 degrees. If you're struggling with those references, you really should be back in chapter 1 of what we were talking about in class over here. All right. So again, I recommend you look at your answer key and make sure you're staring at those answers. All right. So I'm going to go to number 3 now. And whoops, sorry about it. I'm going to blow it up too much, right? And this is in the proper form too. What I mean by that is it's the tangent of an angle equals some fixed number. All right. Again, it might be tough for you, but I'd have to draw one cycle down. I noticed that they really didn't draw one cycle down. I'm going to push this over a little tiny bit, and I'm going to draw my one cycle down for you. Whoops, I'll get red out. Again, my recommendation is to put down one cycle. I'm going to put my asymptotes down. I know they're speaking in degrees. I'm going to continue to speak in degrees. Hey, I'm not saying I'm doing a great picture. So it's going to be x equals 90 degrees, and this is going to be x equals minus 90 degrees. Now, what do I have to do? I have to draw a line now where y is equal to 1. I want to point out this red thing is y equals the tangent. It's just one cycle, though. That's all it is. All right. Now I'm going to draw y equals 1. What does it look like? It looks like this over here. Now, by the way, does it hit it? Right here. Right here. So then the question is, what's the reference? Well, before I do that, I want to emphasize it's got to be between 0 degrees and 90 degrees. I'm looking at the picture. I'm looking at it. So what would do that for me? Well, it's a pretty simple triangle. It's a 45, 45, 90. So the reference is 45 degrees. All right, this is where you get tripped up here. And I'm not trying to trip anybody up. Right, so someone says, what do you mean it trips me up? I got the answer. I know the answer. X is 45 degrees. But I hope you realize that this thing here, as we move forward, and we're moving forward to 360, it's going to hit it again. All right, I point that out to you. You notice that it's going to hit it again over here, and then again over here. And then the question comes is, what's the cycle length for that? Well, I write this down for you. For tangent, the cycle length is 180 degrees. So it's 45 degrees. The next one would occur 180 degrees above that. So what's that number going to give me? X equals, well, 45 plus 180 is 225 degrees. Now, someone says, what's the next one after that? Well, then you would write down 225 plus 180. You're definitely well beyond 360. Okay, so that's done. Again, my recommendation is please look at the answer key. The answers are listed for you. All right, I'm going to go to the next question. I guess that's problem number 4, right? Let me see if 4 is on that page. No, I get the next page. Oops, they're just pictures here. Let's go to number 4. Number 4 doesn't come with a picture. All right, number 4 does not come with the picture. I'll be honest with you, I kind of find that they give me pictures, but I'll go through it. The other problem with number 4 is they're doing 0 to 2 pi. My biggest problem is the secant. I said we just want it in terms of sines, cosines, or tangents. So I have to rewrite this guy. And what's that going to be? It's right to cosine. What's going to be cosine of x is the reciprocal minus 1 over root 2. So I'm going to draw my picture of one cycle of the cosine curve. I'm going to speak in degrees, although I know they're speaking in radians. What does the cosine curve look like? This thing over here. All right? I'm speaking in degrees. 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. That's one cycle of the tangent function. We'll get to the radian measure later. So what do I got to do? I got to put the ratio down now. I'll write this down for you. What's the ratio going to be? Well, I did the red curve. The red curve is y equals cosine x. Now I'm going to do a green curve, and that green curve is y equals minus 1 over root 2. And what does that look like? About minus 0.7. So it looks like this over here. Does it hit it? Yep, right there and right there. What's the reference triangle, though? Let's think about it. It looks familiar to me. The reference triangle is 45, 45, 90. We've done it many times. What's the first angle going to be? X would be, between 90 and 180 with a reference of 45. Well, that's 135 degrees, right? What's the next one going to be? The next one's going to be between 180 and 270 with a reference of 45, and that will be 225 degrees. I need to go to radian measure though. Someone says, why is that? They spoke in radians. So let's write this down. 135 degrees times pi over 180 degrees. The degree symbol would cancel off, and 45 degrees goes into those numbers. It goes in 3 on top, 4 on bottom, so 3/4 of a pi. The other number is 225 degrees times pi over 180 degrees. Degrees cancel off, and 45 again goes into the top 5 times, the bottom 4 times. So these are my solutions over here. Again, I can't say this enough times to you. Please look at the answer key to make sure when you're looking at problem number 4, it says 3 pi over 4 and 5 pi over 4. Let's go to number 5. Again, they don't provide a picture. They're speaking in radians, but I'm not too concerned about that. What I'm concerned about is getting it into proper form. What's proper form? It's either going to be sine, cosine, or tangent. Now look at this thing. I'm clearly saying it looks like a sine problem to me. So what's sine going to be? Sine of x, that's going to be reciprocal, √3 over 2. What do we want you to do? We want you, whoops, sorry about that. We want you to draw one cycle of the sine function. Kind of rough, isn't it? I guess you know those numbers though, right? 0 degrees. Yep, I'm speaking in degrees. 180 degrees, 270 degrees, and 360 degrees. Now what am I going to do? Put the ratio. I'll write this over here. Again, this red curve is y equals sine x, and I'm going to put a green curve down, y equals √3 over 2. Now, √3 over 2 is roughly 0.9, so I'm going to draw that in. A rough picture over here. And I'm not saying it's a good picture, but that's the curve, the green curve. So let's put, did it hit? Yeah, twice. 2 different places. Now, granted, someone can say, I wonder what that triangle is, and I hope you're not wondering too much. I know the reference for that. This is a sine function. So √3, 2, 60 degrees, right? All right, what's the first angle going to be? Well, it's between 0 and 90 with a reference of 60, so 60 degrees. The second one is between 90 and 180 with a reference of 6 degrees. That's 120 degrees. I need to convert these to radian measure. And why is that? They spoke in radians. So let's write that down for you. This will be pi over 180 degrees. This will be 1/3 of a pi, or pi over 3, times pi over 180 degrees. Again, degrees cancel, and 60 goes into 120 degrees. I'm sorry, 60 goes into 120 degrees 2 times, and it goes into 180 degrees 3 times. All right, so these are your answers. Again, you know what I'm going to say. Look at your answer key. What's the answer key going to say? Pi over 3 and 2 pi over 3. All right, let's go to the next one. Ooh, they gave me a picture this time. But now they're giving me a little different story over here. They're saying use n as an integer constant. I notice this picture has numbers in it. And I wouldn't be too concerned about that. I'm more concerned about speaking in degrees to you guys. This is the sine function. I'll speak degrees. Don't worry about that. I like degrees because I'm speaking that since I was childhood. These points should be well known to you. I'll write them down for you. 0, 0 degrees. 90 degrees, 1. 180 degrees, 0. 270 degrees, -1. And this would be 360 degrees, comma 0. All right. So we got the red curve down. What's red curve? Y. I'm sorry. We got the red curve down. Y equals sine of x. You can get faster with practice, by the way. I'm going to put a green curve down. What's green curve going to be? Y equals -1 over √2. That's a negative number. It's about -0.7. Does it hit? Sure does. Here and here. What's the reference triangle? That's pretty simple. 45 degrees. Oh, what's the angle? Well, the angle must be between 180 and 270. I'll write this down for you. So let's see if it's 45 degrees, right? If it's 45 degrees and it's between 180 and 270, what's going to be? X equals, well, 180 plus 45, which would be 225 degrees. All right. What's the next one going to be? Well, the next one is going to be between 270 and 360 with a reference of 45. So that's like going to 360 backing off 45 through 315 degrees. Pat yourself on the back if you got that. Here's the deal though. They want me to use n as an integer constant. So what I'm going to claim over here, the sine function repeats itself every 360 degrees n, where n is some integer. What's the integer is going to be? N could be 0, could be 1, could be 2, could be 3, could be -1, -2, -3, yada, yada, yada. Plus 360 degrees, n. I do want to claim I do not mind this answer, but the Western world is not so kind. They want this in the radian measure. All right. So let me go through that with you briefly. 225 degrees times pi over 180 degrees. This should be simple arithmetic for you. If not, then you have to practice. You got to improve your arithmetic skills. 45 degrees goes into both. 5 pi over 4. So this one's going to be 5 pi over 4. You should know that 360 degrees times pi over 180 degrees is 2 pi. I'll write that down for you. So 2 pi n. What's the other guy going to be? 315 degrees times pi over 180 degrees. Again, the degrees cancel off. And let's see, 7, right? 45 degrees go to 315 7 times. We'll look at the answer. Don't worry about that. And what's 360 degrees? Well, we just did it. It's 2 pi. That's what the world wants. Okay, what I'm going to recommend again is please, I can't say this enough times to you, look at the answer key. We give you an answer key for a reason so you can look at it and verify that. And that's so true when you start to do examples on your own. I'm going to do number 7. Number 7, no picture. At least I don't think there's a picture. There's trouble here though. So what's the trouble? It's not the form I want. So what I have to do is I have to rewrite this guy so it's in the proper form. And what's that going to be? Cosine of x is 1 over root 2. So what you do there? I added 1 to both sides and then I divide it by root 2. What would you do over here? Well, what I've always done. 1 cycle of the cosine. I never grew up picture drawing, you know, never. I think I know those numbers, right? 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Then what do? Well, I just did the cosine, right? Y equals cosine. I'm not going to do that green curve, which is y equals 1 over root 2. Put that down for you. 1 over root 2 is about 0.7, so it looks something like this over here. And I know it hit twice, here and here. All right, let's take a look at it. I need a reference triangle, right? And it gives me a ratio of 1 over root 2. That's pretty simple. See this a lot, don't we? That's 45 degrees. So where's the first guy? And again, I can't emphasize nothing. You're looking at a picture. It's between 0 and 90. Reference is 45. So what's x? X is 45 degrees. The cosine curve repeats itself every 360 degrees and is an integer constant. Let's put the next one down. So it says, what's that one? It's between 270, I'm seeing it, and 360 with a reference of 45. You go 360, back off 45, you're at 315. I don't mind the answer, by the way, but I want to point out the world does mind that answer. So I want to write down a better answer, one with radian. So 45 degrees times pi over 180 degrees. I think you've seen me do this many times before. That's pi over 4 plus, well, 360 degrees times pi over 180 degrees is 2 pi. I think you've seen me do that before. Let's do the next one, which is 315 degrees times pi over 180 degrees. It's divisible by 45 degrees. Now it would be 7 pi over 4. So it's going to be 7 pi over 4 plus 2 pi n. By the way, I'm not beyond making mistakes. So what I want to claim over here is I still want to look at the answer key, and that's problem number 7. So yeah, again, I'm encouraging you to look at the answer key. That's what I'm really encouraging you to do. And if I'm not beyond mistake, you're certainly not beyond mistake. And I'm seeing both of those answers. All right. So let me go to problem number 8 now. Let me see if 8's on this page. I think it's on the next page. Yeah, right there. Oh, geez. I think we've done this one before. They're all the same to me. They really are. What's the problem with this? I don't have a cycle down, do I? I'll put a cycle down for you. Oops, put it in red. Asymptotes go in. I'm still speaking in degrees. It's kind of a sloppy looking picture. Minus 90 degrees. And what's this one over here going to be? 90 degrees. And, you know, y equals the tangent. Write this over here. And now I'm going to put in, you know, y equals root 3. And that's a line. Looks like this over here. Did it hit in a cycle? It did. Right over here. All right. I'm looking for a reference triangle. Pretty trivial. We give you pretty simple problems. At least I hope you find it to be simple. Tangent function, root 3, 1. This would be 2. That's 60 degrees. So my first angle between 0 and 90 with a reference is 60. So the angle is 60 degrees. I'll write that down. The tangent function has a cycle length of 180 degrees. And I like the answer. I don't mind it. The rest of the world is not so kind. So what they want you to do is write in terms of radians. Put this over here, x equals, well, I'll write this down for you. 60 degrees times pi over 180 degrees is pi over 3. 180 degrees in terms of radians. Well, that's simple, just pi, right? I think you know what I'm going to say. Please look at the answer key. And if you're not staring at that answer, something's wrong. All right. All right, let's go to number 9. Oops. Right here. Number 9's trouble. They were nice about it. They gave me a picture. I may not understand the picture until I understand the problem. I got to solve this one though. And I'll write this down for you. So it's going to be cosine squared x. I would add 2 to both sides and divide by 4. And then the cosine squared x equals 1/2. Gee, that's not what I wanted. I want a cosine, right? What's cosine going to be equal to? Plus or minus 1 over root 2. All right, let's do it. Let's go for it. It's tough, but let's go for it. First thing I'm going to put down is y equals cosine of x. Just one cycle of it. Let's put the numbers that I like down. That's, you know, I like speaking in degrees too, by the way. This is going to be 90 degrees, 0. This over here is 180 degrees minus 1. This one over here is 270 degrees, 0. And this one over here, I'm just doing one cycle, is going to be 360 degrees, comma 1. Now what I'm going to do, I'm going to put that line in, and there's 2 lines now. Y equals 1 over root 2, that's up here, about 0.7. And the other one is going to be, let's see, put it in yellow. Y equals minus 1 over root 2. And what's that going to be? What's down over here? That's the yellow line. That's minus 0.7. Does it hit 4 separate times? All right, what do I do now? Reference triangle. What's the reference triangle going to be? It keeps popping up. It's either 30, 60, or 45. What is this going to be? 45. I'm seeing it. Where's the first one occur? X equals, well, between 0 and 90 with a reference of 45 would be 45 degrees plus 360 degrees n. Do the next one. X equals, well, the next one occurs between 90 and 180 with a reference of 45. So that's going to be 180 back away 45, 135 degrees. But if you're spending time with this material, this stuff should be getting easier for you. If you're not spending time with material, it goes off into the bizarre land. I don't understand anything. Now you're between 180 and 270 with a reference of 45. So that's 180 plus 45, which is 225 degrees, plus 360 degrees N. And last but not least, you would get, let's see, 360 back away 45, 315 degrees, plus 360 degrees N. All right. Now, if you write this down in radian mode, that's fine by me. I guess you should do that. I'm getting a little better at this. Let me write them down for you. Whoops, I went backwards. And I apologize for that. So pi over 4 plus 2 pi n. This is 3 pi over 4 plus 2 pi n. This is going to be 5 pi over 4 plus 2 pi n. And this is going to be 7 pi over 4 plus 2 pi n. And again, I'm going to ask you to look at the answer key. Someone says, why do you want me to look at the answer key? I know I'm always right. I never say I'm always right. But what do I notice over there? They got the answers written down over there. Got them all. But then they said there's a simpler way to state it. And by the way, in life, it is best to give simple answers to simple questions. So I'm going to write this down for you. I'm writing in degrees for you, though. 45 degrees, 135 degrees, 225 degrees, 315 degrees. Well, I think if you looked at that and you thought about it, you would see this thing going up. Now, how do you go from 45 to 135? You have to add 90 degrees on. How do you go from 135 to 225? You'd have to add 90 degrees on. How would you go from 225 to 315? Add 90 degrees on. So what I'm going to say is a very simple pattern. What is it going to be? X equals 45 degrees plus some multiple of 90 degrees. If you want to write this down in radian, what would you get? Pi over 4 plus pi over 2 n. This is the gold standard, a nice simple answer. However, I kind of like that as well. They're both good. All right. Again, look at the answer keys. You should be staring at that stuff. All right. We got a number, the last one, I guess it was just, I did, make sure I did what I said I did. I guess that was number 9, right? I guess I got to get a number 10 now. And number 10's right here. And I know what some people are saying. They're saying, you give me problems no one can do. No, we're only giving you problems that relate to what we talked about in class. And what do we got over here? It's going to be either sine of an angle equals a number, cosine of an angle equals a number, or the tangent of an angle equals a number. Well, nearly what I noticed about this thing, it doesn't look like that. So I got to get it to look like that. So what I'm going to do is I'm going to factor it. 2 sine x sine x. I'm using what's known as a zero product rule, 1 and 1. Let's see, minus plus. I'm not saying it worked. I'll try it. Well, 2 sine x times sine x is 2 sine squared x. That worked beautifully. Then I get minus 2 sine x plus sine x, which is minus sine x. That worked beautifully. And we get minus 1. Now I'm going to use the zero product rule. What does it say? Set the factors equal to 0. So let's do the first factor first. That's this one over here. And what does that mean? Well, looking at that, that would mean sine x would have to be equal to minus 1/2. Let's look at the second guy, this guy over here. What's that guy going to be? Well, it's an or what? Or sine of x would have to equal 1. All right, let me write this down now. I got the picture. I'm going to use it. So this is the line y equals 1. And this is the line y equals minus 1/2. Does it hit? It hits it here, here, and here. Now let's start talking about the numbers in degrees, all right? So I'm going to say this is 0 degrees here. This is 90 degrees here. This is 180 degrees here. This is 270 degrees here. And this is 360 degrees here. Now I gotta be honest with you, the first answer looks really simple to me. What am I looking at? It's gotta be 90 degrees. Let's write that down. X equals 90 degrees, but it keeps repeating itself every 360 degrees. And that's gonna be some multiple of that. Now, the other ones might be more complicated for you, but it does give me a ratio of 1/2. And I'm going to say, for sine, by the way, I kind of know what that is. That's a reference of 30. Whoops, sorry about that. That's a reference of 30 degrees. So let's take a look at it. So I'm between 180 and 270 with a reference of 30. So it's 180, go forward 30 degrees. So that would be 210 degrees. Plus 360 degrees n. Let's do the next one. And that's between 270 and 360 with a reference of 30. So what do? Go 360, back off 30, I'm at 330 degrees. Again, it keeps repeating itself, 360 degrees. Okay? So someone said, what are you going to do now? You know what I'm going to do. I'm going to go to that radian measure. All right, I'm going to the radians. All right, let's write that down. That's going to be tough. Nah, not really. We've done it many times before. What's 9 degrees? Pi over 2. What's 360? 2 pi n. What's 210 now? Let me write that one down for you. 210 degrees times pi over 180 degrees. I'm going to say it goes in, like 30 degrees goes into both of those numbers. 7 pi over 6. I'll write that down for you. Let's do 330 degrees times pi over 180. And hopefully you've been practicing, you can do this pretty quickly. 30 degrees again, so it's going to be 11 pi over 6. Yeah, you need arithmetic skills to do these problems over here. All right, so I realize it's tough. A lot of people say it's so tough I can't do it. Yeah, maybe it is so tough you can't do it. But the bottom line, look at the answer key. What do you see? You see those answers. And I'm clearly seeing them. I'm clearly seeing those answers. By the way, don't worry about the simplification problem. But for the most part, I think you guys are doing okay. Let me go to page 8, see what's on page 8. No, just the answer to it. All right. So we're okay. We're good. Thank you.